All right, so here's some information about the distributive property. And the distributive property is used with multiplication. And in this case, we have 6 times, there's nothing in between the 6 and the parentheses, so we assume that is multiplication. So 6 times some variable plus 10. And so what usually happens is we will multiply 6 times x, 6 times each element inside, and we'll start with x. So 6 times x, that is equal to 6x. Then we'll multiply 6 times 10, and that's 60. And 6 times plus 6 times 10. And that's it. That would be your simplified expression, 6x plus 10. There's nothing more you can do about this because they're not like terms. This doesn't have an x multiplied by it, and that's not just a constant, so that's it. Let's work on the next one. I have 7. Now, this whole term inside here, this is set in parentheses multiplied by 7. So the distributive property works the other way too. We can multiply 7 times 5 like that. And 7 times 5 is 35. And then we would multiply 7 times a. And 7 times a is just written as 7a. So that would be plus 7a. And that's it. That is the distributive property. Now, it might get dressed up a little bit more, such as the third one here, 1.5 times 3 minus 4x. But we would still work with it the same way. It would be 1.5 times 3. And 1.5 times 3 is 4.5. So that's 4.5. And then we would multiply 1.5 times 4. 1.5 times 4. And that is 6. And that's 6x. Now we have to be careful here. It was minus 4x. We treat that as a negative 4x. So that would be, at this stage, we can really just say that's minus 6x. But that is a place where students make mistakes, is they will just assume we're just adding that right there every time and not paying attention to that sign that would have to go right here. So the distributive property can be working forwards in distributing and multiplying, but sometimes the distributive property is used in this case where we have a common factor in both terms, and we would create a product of two factors. So the first step in something like this would be to find what is the greatest common factor. I'll do that here. The GCF, the greatest common factor of 3x and 12 is 3. 3 is the biggest number that divides 3x and 12. And so what we would do is we would divide both of these by 3. So from there, what we get is, in this case, the 3's cancel, and we get x plus, and 12 divided by 3 is 4. Now, since we divided everything by 3, that means that in order to make this equivalent, the 3 would have to go outside. So I consider this backwards distributing, where we started with an expression here. We divided by the greatest common factor. We divided that, and that became one of the factors. And we know that we're correct here because 3, if we were to distribute the 3 to both terms here, 3 times x is 3x, and 3 times 4 is 12. It would bring us right back to the beginning. So we have something like this where we have 14 minus 7x. And by the way, maybe I'll just kind of box this here as a final answer there. Now back to our second problem here. The GCF, the greatest common factor of 14, and perhaps I'll say 7x, is 7. 7 is the biggest number that divides both those terms. So we divide both by 7. 14 divided by 7, that is 2. We have a subtraction sign there, and then the 7s will cancel, and we're left with x. And we divided the whole thing by 7, so we have to make sure to keep it equivalent. We multiply this by 7. And that is the distributive property in use right there. So there you go. Thank you for watching, and let me know if you have any questions in the comments.